Hi, this is Algebra 2, Lesson 18. We're going to talk about ratio word problems and similar triangles. We're starting on page 89. A ratio is a comparison of two numbers that can be written as a fraction. So 3/4 can be said is a ratio. It's a ratio of 3 to 4. An equation or other statement that indicates two ratios are equal is called a proportion. So we can say 3/4 is equal to 15/20. Or it's equal to 300 over 400. Or it's equal to 27 over 36. Okay, these are true of fractions. They're also true of proportions. 3:4 as 15:20. 3:4 as 300:400. 3:4 as 27:36. Okay, we could keep going. 3:4 as 111:148. They're proportional. We can show that proportions are equal by cross multiplying. So we have 3:4 as 15:20. If we cross multiply, we have 4 times 15 equals 3 times 20. And if they are truly proportional, this will be a true statement. 4 times 15 is 60, and 3 times 20 is 60. So it's a true statement, and they are proportional. We can solve proportions with one unknown by cross-multiplying and solving for the unknown. 4:3 as 5:k. So we can solve for k by cross-multiplying. We'll have 4k equals 3 times 5. So 4k equals 15. Divide both sides by 4, and k equals 15/4. Okay, let's try some problems. I want to point out this next problem is about horses, not about people. The ratio of Arabian horses to mixed breeds in the herd was 2 to 17. If there were 380 horses in the herd, how many were Arabians? This means that if you divide the herd of 380 horses into two groups, we'll have a group of Arabian horses, pure-blooded Arabian horses, and a group of mixed breeds. So there are Arabian horses mixed with Mustangs or some other kind of horse. Okay, so if you divide the group into two groups, we have an Arabian group and a mixed breed group, and then you divide the number of Arabians and the number of mixed breeds by their greatest common factor, you will be left with a ratio of 2 to 17. Okay? So we don't have just two, we probably don't have just, well, we obviously don't. We have 380 horses, so we don't have just 2 Arabians and 17 mixed breeds. We have 2 times something and 17 times the same number. So what we're looking for, part of what we're going to be looking for, is what the greatest common factor is of the real number that got pulled out, that got factored out to make 2 and 17. Okay? So we can make 3 ratios from the information given. We have the number of Arabians, and in the ratio that we've given, the number of Arabians is 2. And that is going to correspond to the total number of Arabians, whatever the real number of Arabians is. And 2 is to 17. So this is the ratio number of the mixed breed horses in the herd, and that is going to correspond to the total number of mixed breed horses in the herd. Okay? So the proportionally 2 to 17 is going to equal the Arabians to the mixed breeds. Hopefully this is starting to make sense, if you haven't gotten it already. Okay? So that's one ratio we can make with this information. We can also say 2 is to the total number of horses, and what we have is 2 plus 17, so that'll be 19. And that's going to be proportional to the total number of Arabians over the total number of horses, which is 380. Okay, another ratio we could make with this information is the number of mixed breeds to the total number. So that would be 17 to 19 is proportional to the number of mixed breeds to the total number of horses. Okay? We can deal with we have all three of these ratios. They are all proportional, and we need to figure out which one to work with. What we need to know in the end is how many Arabians there are. So we're going to want to work with one of the proportions that gives us A, which is the total number of Arabians. And we want to work with one of the proportions in which we have the most information. This one, we have two unknowns. We have the number of Arabians and the number of mixed horses. This one, we only have one unknown. We only have the number of Arabians. So we're going to work with this ratio. And we're going to solve for the total number of Arabians. So we've got 2 to 19 equals A over 380. And we're going to solve this by cross multiplying. So 2 times 380 equals A times 19. So this is going to be 760 equals 19A. Divide both sides by 19, and the number of Arabian horses is 40. Okay? If we had wanted to solve for how many mixed breeds, we would have used this equation, because it only has one unknown and the rest of them are known. Okay? Let's try another one. It took 600 kilograms of sulfur to make 3,000 kilograms of the new compound. How many kilograms of other materials would be required to make 4,000 kilograms of the new compound? The word ratio is not used, but the problem implies that the ratio of the amount of sulfur to the amount of compound is constant. If the compound is 3,000 kilograms and it contains 600 kilograms of sulfur, it must contain 3,000 minus 600 is 2,400 kilograms of other material. We'll call the other materials NS for not sulfur. So this is what we know. We have 600 kilograms of sulfur. We have 2,400 kilograms of the other material, the not sulfur. And these are the starting quantities. So I'm going to call this sulfur 1 and not sulfur 1. Our original total quantity is 3,000 kilograms. So we're going to call this total 1. Okay? And the final total quantity is 4,000 kilograms. So we're going to call that total 2. So the ratios implied are 600 over 2,400 is going to be proportional to sulfur 2 over not sulfur 2. This is not sulfur 1 and this is sulfur 1 and not sulfur 1. So this is going to be proportional to sulfur 2 and not sulfur 2. Okay? Or we can say 600 over 3,000 is going to be proportional to sulfur 2 over total 2. This is sulfur 1 and total 1, so it's going to be proportional to sulfur 2 and total 2. Or we can say that 2400 over 3000 is equal to not sulfur 2 and total 2. Okay, so this is sulfur, not sulfur 1, this is total 1, and that's going to be proportional to not sulfur 2 over total 2. What we want from the question is how many kilograms of the other materials. So we want a problem that's going to involve the other materials and the total, because that was given in the same statement. So we're going to use this equation. And for total 2, we're going to substitute 4,000. So we have 2,400 over 3,000 equals not sulfur 2, we don't know that quantity yet, over 4,000. Okay? Now we can cross multiply and say that 3,000 times not sulfur 2 equals 2,400 times 4,000. And at this point, you pull out your calculator. And you find, and you divide by 3,000. And you find the amount of not sulfur 2 that we need is 3,200 kilograms. Okay? If we needed 3,200 kilograms, then we needed 800 kilograms of sulfur, because 3,200 plus 800 equals the 4,000. Okay? Now we're going to talk about similar triangles. If two triangles have the same angles, the triangles have the same shape, and they look alike. We call them similar triangles. So here we have triangle A, and its sides are 3, 5, and 7. And here we have angle B, its sides are 6, 8, and 14. And we see that this angle equals this angle equals this angle, and this angle equals this angle. Okay? Triangles triangles A and B have equal angles, so they are similar triangles. The sides opposite equal angles are called corresponding sides. So for this angle, the corresponding side is 6. For this angle, the corresponding side is 3. For this angle, the corresponding side is 5. For this angle, the corresponding side is 10. For this angle, the corresponding side is 14. For this angle, the corresponding side is 7. The ratios of the lengths of corresponding sides in similar triangles are equal and are related by a scale factor. So the scale factor is that number that you that you multiply times 1 to get the corresponding side. Okay? So we can figure out corresponding angles this way. The scale factor. We can find out the scale factor by setting up a problem. So 3 times the scale factor is going to equal its corresponding side. 3's opposite angle is this one with the 1 tick mark. So down here in its similar triangle, we find the other angle with the 1 tick mark, and its opposite angle is 6. So 3 times the scale factor equals 6 because it's its corresponding side. And then we can divide by 3 and find that this scale factor is 2. That means if we're going from, it says left to right, I'm actually going from top to bottom. To go from this similar triangle to this similar triangle, we're going to multiply all of the corresponding sides by 2. And we can check that. 5 times 2 should equal 10 because their opposite angles are equal. 7 times 2 should be 14 because their corresponding angles are equal. Okay? And in this case, it checks out correctly. If we went from the bottom to the top, or from the right to the left, we would say 6 times the scale factor from right to left equals 3. And we divide both sides by 6. And the scale factor from right to left equals 1/2. Half of 6 is 3. Half of 10 is 5. Half of 14 is 7. Okay? Let's try an example. The tick marks tell us that these two triangles are similar. Find the scale factor and then find x and y. So we have 4, 7, and 5, and 3x and y. We see that these two angles are similar, or equal rather. These two angles are equal, and these two angles are equal. Okay? So, the corresponding sides are going to be the ones opposite, right? So we can set those up using the scale factor. We want to solve for x and y. So we should probably start with 4 and 3 because we have constants for both of those numbers. So we can say that 4 times the scale factor from left to right equals 3. And that means the scale factor equals 3/4. And that's going to be true for both of these triangles. The scale factor from left to right is going to be 3/4. Okay? So that means 7 times the scale factor, just 3/4, and we're still going to put this cute little arrow here to show that we're going from left to right. So 7 times the scale factor equals y, and 5 times the scale factor equals x. All right. 7 times 3 is 21/4 equals y. 5 times 3 is 15/4 equals x. And that's your answer. Remember, it does not have to be pretty to be correct. Okay? That is it for this lesson. Try the practice problems and your homework, and let me know if you have any questions. Thanks!